Question 1 asks us to circle the calculation that increases 400 by 7%. Now the answer to this question is 400 multiplied by 1.07. This is only a 1-mark question, you shouldn't spend too long on this, and this should be something that you're quite comfortable with by now. However, we can adopt a bit of logic to those who are struggling. Well, we need to increase the number by 7%, so the number needs to get bigger. Now if we multiply a number by 1, it stays the same size, i.e. it doesn't increase or decrease. So if we look at the first two options, which is 400 multiplied by 0.07 and 400 multiplied by 0.7, they both make the number smaller. It is going to decrease, so we can get rid of those options straight away. So that leaves us with the other two, which is 400 multiplied by 1.07 and 400 multiplied by 1.7. Well, if we're multiplying a number by 1.7, 1.7 is very close to 2, we're nearly multiplying it by 2, we're nearly doubling it, i.e. it's nearly increasing by 100%. So we know just off that logic alone it has to be 400 multiplied by 1.07. In the exam though, you should be very confident at doing this type of calculation. So for example, if I wanted to increase 400 by 30%, I would do 400 multiplied by 1.3. Likewise, if I wanted to decrease 400 by 30%, I would do 400 multiplied by 0.7. Now let's have a look at question 2. This asks us to simplify 3 to the power 4 multiplied by 3 to the power 4. This is going to test our knowledge of the rules of indices. So remember, if we have x to the a times by x to the b, we just add the powers, so we get x to the a plus b. Okay? So in this example we've got x is 3, a is 4, b is 4. So 3 to the 4 multiplied by 3 to the 4 is going to be 3 to the 4 plus 4, which is obviously 3 to the power 8. So that is our answer. Finally, let's have a look at question 3. So this asks us to circle the area that is the same as 5.5 meters squared. Now notice that all the possible answers are in terms of centimeters squared. So this question is asking us to convert meters to centimeters. Well, we have 5.5 meters squared. Well, that's the same as 5.5 meters times meters, because meters squared is just meters times meters. And that's the same as 5.5. Well, how many centimeters are in 1 meter? Well, that's going to be 100 centimeters times 100 centimeters. So all I've done here is replaced meter by 100 centimeters. So we can see the calculation we need to do. We've got our centimeters times centimeters, that's our centimeters squared. And now we just need to do 5.5 multiplied by 100 and multiply it by 100 again. So if you do 5.5 multiplied by 100, well, that's going to give us 550. And then we need to multiply that by 100 once more. So the answer is going to be 55,000 centimeters squared. In question 4, we are given a sketch of y equals 1 minus 2x. This is a straight line. And the question asks us to circle the correct letter that corresponds to the graph of y equals 1 minus 2x. Well, remember, an equation of a line has the form y equals mx plus c, where m gives us the gradient and c gives us the y-intercept. So in this equation here, the intercept is 1. And what that means is that our graph is going to look something like this. It's going to cross the y-axis at the point 1, okay? So already, we know that it can't be C or D. They both cross the y-axis at minus 2. So the answer is going to either be A or B. Well, what's the next clue we can use? Well, we can see that the gradient here is minus 2. Now, if a straight line has a positive gradient, it's an increasing function. It slopes like that. If it's got a negative sign, it's a decreasing function, and the slope goes that way. So we're after a line that crosses the y-axis at the point 1 and slopes this way. And we can see from the 4 possible options that the answer must be B. Question 5 gives us a scatter graph that shows the age and price of 18 cars. We are given that the cars are the same make and model. The question asks us to use a line of best fit to estimate the price of a 6-year-old car. So the first thing we need to do is to draw our line of best fit. Make sure you use a ruler for this, guys, okay? Now we have our line of best fit, the next thing we need to do is to scroll on the x-axis until we find the age of 6. We then draw up until we meet the line and see what y-coordinate that corresponds to. And we can see from the graph that that corresponds to a price of 3,400. So the answer is 3,400. Question 6 tells us that Kelly is trying to work out the two values of w for which 3w minus w cubed equals 2. Her values are 1 and minus 1. Are her values correct? We must show our working. In this question I wouldn't worry about trying to solve this equation. All we need to do is to put in her values of w and see whether we get the answer of 2. If that's the case, her answers are correct. So let's start with w equals 1, her first answer. And we need to put that into 3w minus w cubed equals 2. So substituting w as 1, we get 3 times 1 minus 1 cubed equals, and we're going to see if that equals 2. Well, 3 times 1 gives us 3. 1 cubed is 1, so we get 3 minus 1, which is 2. That's correct. So we know that w equals 1 is one solution. Let's try w equals minus 1. So we're going to get 3 times minus 1 minus, and then replace w in minus 1, we get minus 1 cubed. What does that equal? 3 times minus 1 gives us minus 3. Then we've got minus, and what's minus 1 cubed? Well, minus 1 cubed is minus 1, because minus 1 times minus 1 gives us 1, times by minus 1 again gives us negative 1. Be careful with the double minuses here, guys. That's where most people are going to slip up. And if we do that, we're going to get minus 3. The minus minus there gives us a plus. Plus 1, which is minus 2. That does not equal 2. So this means that w equals minus 1 is not a solution. So Kelly is not correct. Question 7 asks us to work out 2 3/4 multiplied by 1 5/7. We are asked to give our answer as a mixed number in its simplest form. So to tackle this question, the first thing I would do is write these mixed fractions as improper fractions. So we've got 2 3/4. So we've got 2 whole ones and 3/4. Well, what is 2 whole ones in terms of quarters? Well, that's going to be 8/4, yeah? Because 8 divided by 4 is 2. And then we've got another 3/4. So that's our first term. So our 2 plus another 3/4, because 8 divided by 4 is 2. And we need to multiply that by what? Well, we've got 1 whole 1 and 5/7. Well, 1 whole 1 in terms of sevenths is 7/7. 7 divided by 7 is 1. And then we've got this extra 5/7 as well. Let's add these together to get our improper fractions. So 8 plus 3 is going to give us 11. So we've got 11 over 4. Times by, and this we've got a 7 plus a 5, which is a 12. 12 over 7. Remember, we can add the numerators of fractions so long as the denominators are the same, which they are in this case. So now we're doing 11/4 times 12/7. Well, we can do a little bit of cross-cancelling here. Notice that 12 is 4 times 3. So we can cancel those. That becomes a 3, and that becomes a 1. And now to do a multiplication with fractions, we times the top by the top, the bottom by the bottom. So we have 11 times 3, which is 33. And on the bottom we have 7 times 1, which is 7. This is the answer, but remember, we were asked to give it as a mixed number in its simplest form. So we need to write this as a mixed number. How do we do that? Well, let's see how many 7s we can get into 33, and let's see what the remainder is. Well, 7 4s are 28, yeah? So we have 4 whole lots of 7s in that, and then we've got the difference between 28 and 33, which is 5, so we've got 5 7ths left over. So the answer is 4 and 5 7ths. Essentially what I've done in that last step is I've said, well, 33 over 7 is the same as 28 over 7 plus 5 over 7, but we know what 28 over 7 is, that's 4. So it's 4 plus 5 7ths, which is just 4 and 5 7ths. Question 8 asks us to solve the following inequality. 5x minus 2 is greater than 3x plus 11. The way I would solve this is to get all the x terms on one side. So if we minus 3x from both sides, okay, so we're going to take away 3x from both sides of this inequality, we're going to get that 2x minus 2 is bigger than 11. And now we could add 2 to both sides of this inequality. So we're going to get 2x is greater than 13. And now we've got the x's all on one side. To finish this off, all we need to do is divide both sides by 2. So if we divide both sides by 2, we're going to get that x is greater than 13 divided by 2, or 6.5. And that is our answer. Question 9 gives us two nth terms of two different sequences, 2n plus 1 and 3n minus 1. And the question asks us to work out three numbers that are in both sequences and between 20 and 40. Now, for those of you who may go on to study number theory at a higher level, there are quite rigorous ways of doing this, but for the purposes of the GCSE exam, I suggest we cleverly list all possibilities and then circle the ones that are the same. So we need to choose a starting point. We don't want to be writing down an unnecessary amount of numbers here. So if I picked n as 1, for example, in this sequence, I would get 2 times 1, which is 2, plus 1, which is 3. It's nowhere near 20. So let's try another number. Let's try n is 10. Well, if I put n is 10, I get 2 times 10, which is 20, plus 1, which is 21. Cool, let's list that down. Now let's try the next number, n is 11. Well, we're going to get 2 times 11, plus 1, which is going to give us 22 plus 1, which is 23. In fact, because we have a sequence where the coefficient of the n is 2, we know that the difference in this sequence is 2, so we can just write down the list as follows: 23, 25, 27, 29, 31, 33, 35, 37, 39, and if we go any higher we're going to get greater than 40, so we'll leave it there. Now let's do the same for this sequence. Let's try n as 5, so we would get 3 times 5, 15 minus 1, which is 14. A bit low, so shall we try n as 7? Well, we're going to get 3 times 7, which is 21, minus 1, which is 20. Now the coefficient of n in this sequence is 3, so the numbers are going to increase by 3 each time. So we're going to get 23, 26, 29, 32, 35, 38, and then if we go any higher, we're going to get past 40. So let's find the numbers that are the same. Well, they've both got a 23, they've both got a 29, and they've both got a 35. So the answer to this question is going to be 23, 29, and 35. Question 10 tells us that white paint costs £2.80 per litre and blue paint costs £3.50 per litre. We are given that white paint and blue paint are mixed in the ratio 3 to 2. And we are asked to work out the cost of 18 litres of the mixture. Now this is quite a tricky question. So the first thing I would do is deal with the ratio. So in the ratio we have 3 parts white paint, 2 parts blue paint. So in total there are 5 parts to the ratio. 3 parts plus 2 parts is 5 parts. And that's equal to 18 litres of the mixture, because we want 18 litres in total. So that tells us that 1 part is equal to 18 divided by 5, which is 3.6 litres. Remember, dividing by 5 is the same as dividing by 10, then multiplying by 2, so that's how I did that quickly. 18 divided by 10 is 1.8, multiplied by 2 is 3.6. The reason we've done this is because we now know what 1 part is equal to, and we know 3 parts are white paint, 2 parts are blue paint. So 3 parts must be equal to 3.6 times 3, which is 10.8 litres. So we need 10.8 litres of white paint. And 2 parts must be equal to, well, we need to multiply this 1 part equation by 2 to get 2 parts. So we get 3.6 times 2, which is 7.2 litres. Now, of course, 10.8 and 7.2 add up to 18 litres, which is what we would expect. There are 18 litres in total. Cool, so we now know that we need 3 parts white paint, 2 parts blue paint, and that equates to 10.8 litres of white paint, 7.2 litres of blue paint. Let's start with the white paint first. So if white paint costs £2.80 per litre, and we need 10.8 litres, we just need to do a multiplication here. Many ways of doing this. I think I'll do it in a grid for now. 0.8 times 0.8 is 0.64. 0.8 times 10 is 8. 2 times 0.8 is 1.6. And 2 times 10 is 20. And if we add all of those guys up, we are going to get £30.24. That's the costs of the white paint. We need to do the same for the blue. So we are told that blue paint costs £3.50 per litre, and we need 7.2 litres. So we're going to do 7.2 multiplied by 3.5. 0.2 times 0.5 is 0.1. 0.5 times 7 is 3.5. 3 times 0.2 is 0.6. And then 7 times 3 is 21. We can add all those up, and we're going to get 11, 12. So we're going to carry 1, 4, 5, so we get 25.2. So the cost of the white paint is £30.24, the cost of the blue paint is £25.20. So we just need to add these guys up, and if we do £30.24 and add that to £25.20, then we are going to get £55.44. That's the answer. In question 11, we are told that students in a class took a spelling test, and the diagram shows information about the scores. We are told that Lucy is one of the 29 students in the class, and her score was the same as the median score for the class. And we need to work out her score. But what do we need to do here? Well, the median is always given by the n plus 1 divided by 2 number, where n is the number of people in a sample, in this case the number of students in the class. So for us, n is 29. So the median is going to equal the 29 plus 1 divided by 2th number, and that is 30 divided by 2, which is the 15th student. Now this is assuming that all the marks were put in ascending order, from smallest to largest, which conveniently in the graph this is done for us. So what we need to do is we need to count the frequencies starting at a score of 3 and going all the way up until the total frequency is 15. So we're essentially looking for the bar in that chart that contains the 15th number. So let's start with a score of 3. Well, 2 people got that. When we go to a score of 4, another 2 people got that. So that's 2 plus 2, which is 4. Then we go to a score of 5, we got another 4 people got that. Plus the 4 we had originally is going to give us 8. And then with score 6, 7 people got score 6. Plus the 8 we had originally, that's 15. So there we go. We can see that the bar that contains the 15th person is the bar representing a score of 6. Therefore, Lucy's score was 6. In question 12, we are given this L shape, and we are asked to show that the total area of the L shape in centimetres squared is x squared plus 9x plus 27. we are given that ABCH, so this shape here, is a square. And that's useful because we know that the sides then are all the same length. So this tells us that BC must be x plus 3 centimetres, so must HC, that must be x plus 3 centimetres, and likewise AH is x plus 3 centimetres. We are also told that HCFG is a rectangle, so HCFG, this here is a rectangle. So what we can deduce from this is that two of the sides must be the same as each other, and the other two sides must be the same as each other as well. Now we can see from the diagram that the length D to E is 3 centimetres, so we know that H to G is 3 centimetres. And because this is a rectangle, we know that G to F is obviously x plus 3 centimetres, and CF must be 3 centimetres. And we are told that CDEF is a square, so we know that these sides here are 3 centimetres as well. So there's a few ways of working out the total area. I think the way I am going to do it is I'm going to look at adding these three shapes together. Okay? So let's start with this shape here. This is a square with side length x plus 3. So the area of that must be x plus 3 all squared. Let's add to that the area of this rectangle here. Well, one of the sides is 3 centimetres and the other's x plus 3. So we've got a 3 times by x plus 3. Remember, in a rectangle we times the length of the shorter side by the length of the longer side. That gives us the area. And finally we need to add it to the area of this square here. Well, the side length of the square is 3, so the area of that square is 3 squared. Let's do some expanding brackets here. So x plus 3 all squared gives us x squared plus 6x plus 9. We need to add that to this, and if we expand that out we get 3x plus 9, and then we add that to 3 squared, which is of course 9. Let's collect like terms. Well, we've only got one x squared term, so we leave that there, that's done. Let's collect our x terms, so we've got a 6x plus a 3x, well that's a 9x. And then we've got three constant terms, which are 9s, to add together, so we get 9, 18, 27. So the area of the total shape is x squared plus 9x plus 27, which is what we were asked to show. In question 13 we are given sketches of 4 triangles. We are told that in each triangle the longest side is exactly 1 centimetres, and the other length is given to 2 decimal places. The question asks us to circle the value of cos 50 to 2 decimal places. So remember from trigonometry, if we have a right angled triangle and we have an angle x that we'd like to work out, then we call the diagonal of the triangle, the length opposite the right angle, the hypotenuse. We call the length opposite the angle, the opposite, and the length to the side of the angle, the adjacent. And we know that cos x is a over h. We also know that sin x is o over h, and tan x is o over a. Now in this question we are asked to find cos of 50 degrees. So what we need is a right angled triangle, and then we need an adjacent and a hypotenuse. So let's look at the first triangle on the left. Well, that's a right angled triangle. We have a hypotenuse of 1, and we have an opposite of 0.77. Now we could actually use this, we could use a bit of Pythagoras to work out what cos 50 would be, but that's a waste of our time. So let's move on to the next one. So if we look to the right, we can see that that's not a right angled triangle, so let's forget that as well. If we look at the bottom left one, that is a right angled triangle. We are given a hypotenuse and we are given an adjacent. That's exactly what we want. Finally, the bottom right triangle is also not a right angled triangle. So if we look at the bottom left one, we can see that the adjacent is 0.64 and the hypotenuse is 1. So cos 50 is 0.64 divided by 1, which is 0.64. So that's our answer. It's probably also worth noting that if we did try and use Pythagoras on the top left triangle, that we would have to compute a square root, which is very difficult without a calculator, but also because these angles have been rounded, it's likely we wouldn't get an exact answer anyway. So this question is expecting you to use the bottom left graph. In part B, we are given another triangle and we are asked to work out the value of x, and we need to give our answer to 1 decimal place. Now notice that we have a right-angled triangle, we are given the hypotenuse, and we need to find the adjacent to the angle, which is x. Notice that the angle in this triangle is 50 degrees. Now we know from the previous part that cosine of 50 is 0.64. So let's use that to work out x. Well, we know that cos 50 is equal to a over h, the adjacent over the hypotenuse. The adjacent here is x, and the hypotenuse is 4, so cos 50 is x over 4. But we know that cos 50 is 0.64, so this must equal 0.64. So we can ignore this stuff on the left here, and we just need to solve that equation for x here. So we're going to get that x equals 4 times 0.64, which is going to give us 2.56 centimetres. Now we need to give our answer to 1 decimal place, so round it to 1 decimal place. This gives us 2.6 centimetres. Notice when we're multiplying by 4, that's the same as multiplying by 2 twice. So multiplying 0.64 by 2 gives us 1.28, multiplying that by 2 once again gives us 2.56. In question 14, we are given that a prime number between 300 and 450 is chosen at random. And we are given this table that shows the probability that the number lies in different ages. So for example, we can see from the table that the probability that the prime number n is greater than or equal to 300, but strictly less than 330, is 0.16. In part A, we are asked to work out the value of x. Well, we are given all the probabilities on the right-hand side, and remember, the probabilities must add up to 1. How do we know that they add up to 1? Well, the prime number is between 300 and 450, and the table covers all possible ranges between 300 and 450. Therefore, the probability that the prime number is between 300 and 450 is obviously 1, because we are told that it's between 300 and 450. So all we need to do is add up all the probabilities, and these should equal 1. So we need to do 0.16 plus 0.24 plus x plus 0.16 plus 0.24. And we know, because these are probabilities, they add to 1. Okay, let's combine some of these. Well, the 0.6 plus another 0.6, that's going to give us 0.32. And then we're adding that to 0.24 and another 0.24. Well, that's a 0.48. And then we're adding our x, and that equals 1. If we add these two together again a little further, we're going to get 0.8 plus x is 1. Rearranging, taking away 0.8 from both sides, we're going to get that x equals 1 minus 0.8, which is 0.2. So the probability that n is greater than or equal to 360, but strictly less than 390, is 0.2, or 20%. And that is the answer to part A. In part B, we are asked to work out the probability that the prime number is greater than 390. So we want the probability that n, our prime number, is greater than 390. And this is the notation I tend to use. So I have a p open brackets, so the p means probability, and then the thing in brackets means the thing I would like to know the probability of. So I'm looking for the probability that n is greater than 390. Well, we are going to have to use the table for this. We know that n is between 300 and 450. So if we want the probability that n is bigger than 390, this is essentially the probability that n is bigger than 390 and less than 450. Well, we can see from the last two rows of the table that the probability that n lies between 390 and 420 is 0.16. But we know it could be all the way up to 450. So we need to add to that the probability that n could be between 420 and 450. So we need to add to that 0.24. And if we do that, we get 0.4. So the probability that n is bigger than 390 is 0.4, or 40%. In part C, we are told that there are 4 prime numbers between 300 and 330. And the question asks us how many prime numbers are there between 300 and 450. Well, if we go back to our table, we can see that the probability that n is between 300 and 330 is 0.16. So let's let t equal total number of primes between 300 and 450. Now we are told that there are exactly 4 that lie between 300 and 330. The probability that the prime number lies between 300 and 330 is 0.16. So 0.16 times the total amount of primes in that range must give us 4, because that's what we're told. But we want t, we want the total number of primes between 300 and 450. So we just need to divide both sides of that equation by 0.16. So t, the total number of primes, is 4 divided by 0.16, which is 4 divided by 0.16. And the way I'm going to do this is treat that as a fraction. So that's 4 divided by, well, 0.16 is 16 100ths. And if we divide by a fraction, we multiply by its reciprocal. So that's the same as 4 multiplied by 100 over 16. Which is, I'm going to do a bit of cross-cancelling here. So we've got 4 and a 16, they cancel, so that becomes a 1. 16 divided by 4 gives us 4. So we're given 100 over 4, which is 25. Feel free to cancel that further. We could have said that's the same as 50 divided by 2, which is 25 over 1, to get the answer of 25. In question 15, we are given this complicated expression here, where a is a number, and we are asked to work out a times 10 to the 4 minus a times 10 squared, and give our answer in standard form. Now I think this is a really tricky question. So one way of doing it would be to solve this for a, and then to go back and put that into the expression. But the problem is, this is only a 2-mark question, and that would take quite a lot of time, and you would need to be quite good with your division. Instead, we're going to approach it in a different way. So notice, here we have a times 10 to the 4 plus a times 10 squared. So something times 10 to the 4 plus the same something, but times 10 squared. Notice the repetition here, so we've got a 24 and a 24. So let's split this up and write this in terms of standard form. Well, 24,240 is 24,000 plus 240. Yeah? How did I spot that? It's the repetition of the 24s there, okay? Because I know I can write this in terms of 10 to the power something, and write this in terms of 10 to the power something. In fact, 24,000 is going to be in standard form 2.4 times 10 to the 4, and 240 in standard form is going to be 2.4 times 10 to the 2. This is interesting, because here, on the left, we've got something times 10 to the 4, plus the same something times 10 to the 2. And on the right hand side, we've got something times 10 to the 4, and the same something times 10 to the 2. So that tells us that a times 10 to the 4 is 2.4 times 10 to the 4. In other words, a is 2.4. Well, that's good. But we need to evaluate a times 10 to the 4 minus a times 10 squared. But notice, we have a times 10 to the 4. That corresponds to 24,000. And the a times 10 to the squared corresponds to 240. So a times 10 to the 4 is 24,000. And we need to take away from that a times 10 to the 2, which is 240. So we need to do 24,000 minus 240. I'm going to do this the long way around. 0 minus 0, 0. 0 minus 4 can't do, so we need to carry. That 4 becomes a 3. That becomes a 10. We need to carry once more, so that becomes a 9. And we carry here. 10 minus 4 is 6. 9 minus 2, 7. 3 minus 0 is 3, 2 minus 0 is 2. So we have 23,760. But be careful, we need to write our answer in standard form. So this is going to be 2.376 times 10 to the power 4. And that's the answer. In question 16, we are given that AB, CD and YZ are straight lines. We are told that all angles are in degrees. The question asks us to show that AB is parallel to CD. In other words, this line here is parallel to that line there. So how can we do that? Well, if they're parallel, then this angle should be equal to that angle. This is the corresponding angles rule. So how can we show that? Well, we know that angles in a straight line add up to 180. So let's first work out what x should be. Well, we know that this angle plus this angle should equal 180 degrees. So let's write down an expression for that. We're going to get x plus 25 plus 2x plus 35 equals 180. If we clean this up a little bit, we're going to get x plus 2x gives us 3x, plus, and then we've got a 25 plus a 35, and that is going to give us a 60, and that equals 180. If we take 60 away from both sides, we get 3x is equal to 120, and this tells us that x equals 40. So now what we're going to do is plug this value for x into that angle there and that angle there and see if they're the same, and if they are, we know that AB and CD are parallel. So let's start with 2x plus 35. Well, this is going to give us 2 lots of 40 plus 35. Well, that's 80 plus 35, that's 115. So let's see whether this is 115 degrees as well. So 5x minus 85 equals 5 lots of 40 minus 85. 5 lots of 40 gives us 200, minus 85 does indeed give us 115 degrees. Since these angles are equal, they must be parallel. In question 17, we are told that to complete a task in 15 days, a company needs 4 people, each working 8 hours per day. But the company has decided to have 5 people working for 6 hours per day. And part A asks us how many days will the task take to complete. You must show you're working. So let's have a look at total number of hours. Total number of hours. So the total number of hours, if it's going to take 15 days, is going to be 15 days multiplied by the 8 hours, and then 4 people are doing this. So we need to do that calculation. Let's do 15 times 32, and 15 times 32 is the same as 10 times 32, which is 320, plus 5 times 32, which is half of that, which is 160. So altogether that's 480 hours in total. Okay, that's how long it takes. But we are told that the company decides to have 5 people, each working for 6 hours per day. So each day they work 5 times 6 equals 30 hours. So we need to divide the total amount of time divided by the total amount of time in each of these days. So that's going to be 480 divided by 30. Well, that's 48 divided by 3. And that comes out as 16. If you were struggling to get that, you could do this via long division if you would like. So we could say we have 48 up here. What's an easy number of 3s we can pick out? Well, I could take 10 3s, that's 30. And then we do 8 minus 0 is 8, 4 minus 3, 1, 18. Well, I know that that is 6 threes, and 10 plus 6 gives us the answer of 16. So the answer is going to be 16 days. Now in part B, we are asked to comment on how the assumption affects our answer to part A. Now the assumption here is that each person works at the same rate. This affects our answer to part A because if the people working less hours were more productive, for example, then this would take less time. Likewise, if people were working at a slower rate, the answer is going to be higher. That's the kind of line we need to do to guarantee that 1 mark. In question 18, we are given this solid and we are asked to work out an expression for the total volume of the solid. Now notice that this is a prism, so it has a uniform cross-section, and the area of a prism is always the area of the cross-section times its length. Okay? So let's deal with the area of the cross-section first. So we've got a rectangle here, and then we've got a semicircle at the top. So what's the area of the rectangle? Well, that's going to be the width times the length. So it's going to be 2x times x, which is 2x squared. What about the area of the semicircle? Well, it's going to be half the area of a circle, and the formula for that is going to be half pi r squared. But what is r? R is the radius. And we can see that the diameter of the circle, or the semicircle, is x. So the radius is x over 2. So this is going to be a half pi times the radius, which is x divided by 2, all squared. Remember, the whole radius, x over 2, is squared. And if we simplify this, we're going to get that half is going to square to a quarter, times by another half gives us an eighth. Then we've got a pi x squared. So the area of the cross-section is going to equal that plus that. So in other words, we're going to get 2x squared plus 1 over 8 pi x squared. But remember, this is a prism, and the length of the prism, or its thickness, is x. So the area of the solid is going to be that expression all multiplied by x. In other words, 2x cubed plus 1 over 8 pi x cubed. In this question we are asked to show that 12 cos 30 minus 2 tan 60 can be written in the form square root k, where k is an integer. Now cos 30 and tan 60 are two angles that you are expected to know off by heart for this examination. However, if you don't, I'll show you a very quick way of deriving them. The way I would do it sometimes if I forget is I start with an equilateral triangle, all with side length 2. Doesn't matter what side length you pick, but you'll see why 2 is quite a nice number. Obviously, every angle is 60 degrees, right? Because it's an equilateral triangle. Now let's just cut that in half. And let's just look at this right-hand side. So I'm going to draw that here. Well, the hypotenuse of this right angle triangle is 2. Notice that this is a right angle here, so that's a right angle. What's this side going to be? Well, it was 2, we've cut it in half, so it's 1. And what about this guy here? How can I find that? Well, this is a right angle triangle. So I can find that by using Pythagoras. In fact, we know that 1 squared plus whatever that is squared, I'm going to call that b. b squared is c squared, which is 2 squared, which is 4. So this is saying that 1 plus b squared is 4. This tells me that b squared is 3, which tells me b is the square root of 3. So that's the square root of 3. Why is this useful? Well, we know that angle is 60 degrees, because it was in the equilateral triangle. And this angle is what? Well, it's 60 degrees divided by 2, which is 30 degrees. So now we can see immediately, by using this, we know that cos 30 is going to be a over h, so the 30 is there, so that a is root 3, and h is 2, so root 3 over 2. Now what about tan 60? Well, tan 60, that's O over A, where 60 is now our angle. So O is root 3, that's root 3, divided by A, which is 1. So get root 3 over 1, which is just root 3. So that tells us that 12 cos 30 is 12 times that. Well, that's going to be 12 times root 3 over 2. And we need to take away from that 2 tan 60, which is 2 root 3. Well, let's just clean this up a little bit. That's going to be 12 and the 2 cancel. So we're going to get a 6 root 3. So we get a 6 root 3 minus 2 root 3. Well, that's going to give us a 4 root 3. But be careful. It wants the answer in the form square root k. So we need to get this all under the square root sign. So this is root 3 times by 4. But what's 4 as a square root? That's the square root of 16. And now we can times the 3 and the 16 together, and we're going to get 48. So this is the square root of 48. So that's our answer. K is 48. So in question 20, we are told that on Friday, Greg takes part in a long jump competition. He has to jump at least 7.5 metres to qualify for the final on the Saturday. He has up to 3 jumps to qualify. If he jumps at least 7.5 metres, he does not jump again on the Friday. Each time Greg jumps, the probability that he jumps at least 0.5 metres is 0.8. We assume that each jump is independent. What we mean by that is, if Greg knew the outcome of his first jump, it's not going to affect his chance of success in the second and third jumps, etc. In part A, we are asked to complete the tree diagram. So I've started it off with the first jump, second jump and third jump. Now notice, he either qualifies, i.e. jumps at least 7.5 metres, or he doesn't. If he qualifies, that's it, done. He doesn't need to do anything else, so it just stops there. If he doesn't qualify, he gets another chance. In which case he might qualify and stop, he's done. Or he doesn't qualify. And if he doesn't qualify, he gets his final chance, third and final chance, in which he might qualify or not qualify, and then he won't be in the final. So let's complete the diagram. So if the probability on the first jump of him qualifying is 0.8, then the probability of not qualifying is 0.2. Remember, probabilities add to 1. He can either qualify or not qualify. There's no other possibility there. Now the jumps are independent, and we're told that his probability of jumping at least 7.5 metres is 0.8. So that's going to be a 0.8. That's going to be 0.2, that's going to be 0.8, and that's going to be 0.2. Let's have a look at part B. So this wants the probability that he does not need the third jump to qualify. So at the probability, do not need third jump. Let's think about this logically. If he doesn't need the third jump to qualify, that means he must qualify either in the first jump or the second jump. Okay? So this is the same as the probability that he qualifies in the first jump plus the probability that he qualifies in the second jump. Now what's the probability that he qualifies in the first jump? Well, we can see from the diagram that's 0.8. And we need to add to that the probability that he qualifies on the second jump. Well, what's the probability that he qualifies on the second jump? Be careful. To qualify in the second jump, he must first have failed to qualify in the first jump, and then qualify in the second jump. So we need to look at kind of this pathway here. Doesn't qualify, and then qualifies. And what's the probability of that? Well, he needs to first not qualify, so the probability is 0.2. And then he needs to qualify, which is 0.8. Okay? So we need to add these up. We're going to get 0.8 and we need to add to that 0.16. And if we do that, we're going to get 0.96. So that's the answer. In question 21, we are told that A, B and C are points on a circle. BC bisects angle ABQ, and PBQ is tangent to the circle. We are given that angle CBQ equals x, and we are asked to prove that AC equals BC. In other words, we need to show that the length of that line there is the same as that one here. This is one of these circle theorem type questions, and what we need to do is use the information we are given. So let's use the first bullet point. This says that BC, i.e. this line here, bisects angle ABQ. So what's angle ABQ? Well, it's this one here. So if I highlight that, what that means, if it says bisect, is it cuts it in half. So BC there cuts this whole angle in half. But we know what half of the angle is, it's x, so that tells us that this angle there is x, because BC has bisected this big angle, cut it into two pieces. But we can also use the alternate segment theorem, because we are told that PBQ is tangent to the circle. So this is tangent to the circle, so that angle there is equal to the opposite one in the triangle. So that's also equal to x. Well, that's interesting, because we have a triangle where two angles are the same. Therefore it's isosceles. Therefore, these are the same. To get full marks for this question, we obviously need to write down what we've just said. So the first thing I would say is BC bisects ABQ. So we know that angle ABC is x. Then we need to say that alternate segment theorem that implies that angle BAC is also x. Therefore, ABC isosceles. Therefore, AC equals BC, and that would warrant you full marks. In question 22, we are told that Steph is solving a problem. There's cube A that has a surface area of 150 centimeters squared, and cube B that has sides half the length of cube A. She's asked to find the volume of B. To solve this problem, she's come up with her own method, and we need to evaluate her method. Well, let's just have a look at what we know. We know that the sides of cube B are half the length of cube A. So if we pretend that the sides of cube B are all x, then the sides of cube A are all obviously going to be 2x. So what's an expression for the surface area of A? Well, the surface area of A is going to be 6 times by the area of the faces. Why? Well, it's a cube, so there are 6 faces, and they each have area 2x all squared. Because the area of each face will be 2x times 2x. And that's going to be 4x squared times by 6, which is 24x squared. What about the surface area of B? Well, the surface area of B is going to be 6 times the area of the faces of B, which is x times x, x squared. So that's 6x squared. So we can see already, looking at the first step in Steph's method, she's made a mistake. She would need to divide the surface area by 4, because 24 divided by 4 gives us 6, not by 2. If she divides by 2, that's saying the surface area of B is equal to 12. So I would say that Steph has made a mistake. She needs to divide by 4, not 2. Just to ensure we get the full marks, why don't we quickly suggest the correct approach? So we want to divide the surface area of cube A by 4. That gives us the surface area of B. Now what do we need to do? Well, we then need to divide surface area B by 6, and that's going to give us x squared. Then we're going to square root it, the answer. That's going to give us x, and then we're going to cube the answer, and that's going to give us x cubed, i.e. the volume of B. In question 23 we are given a square, OABC, that is drawn on a centimetre grid. Now we are told that OABC is translated by the vector 3, 1. So that means the square moves 3 units to the right and 1 unit up. We are asked to circle the number of invariant points on the perimeter of the square. You can think of this as the number of points that stay in the same position, if you'd like. So if we translate the vector by 3, 1, we can see that none of the points stay in the same place, therefore the answer is 0. In part B we are told that the square is enlarged by a scale of factor 2 about the centre. If we visualise doing that enlargement, we will see that the only point that stays in the same place is the centre, which is 0, 0. So the answer to this is 1 invariant point. Finally, in part C, we are told that the square is reflected in the line y equals x. Again, if we visualise this, the point 0, 0 and 2, 2 will remain unchanged, but the other two corners will essentially flip over each other. So the answer to this is 2. In question 24 we are given a velocity time graph of a car over a 50-second period. And in part A, we are asked to work out the average acceleration during the 50 seconds, and we need to give the units of our answer. Well, we can see from the graph quite easily that over the 50 seconds we got up to a velocity of 30 meters per second. If we've got up to a speed of 30 meters per second in 50 seconds, that means that our average acceleration was going to be 30 divided by 50, which is 3 divided by 5, and to divide by 5 that's the same as dividing by 10, then multiplying by 2. So that's the same as 0.6. But what's the units for this? Well, essentially we've done meters per second, so meters divided by seconds, divided by seconds, because we've done our 30, which is in meters per seconds, divided that by seconds, so we've done meters per seconds, divided by seconds, so the units are going to be meters per second squared. So the units we want here are meters per second squared, and that's the answer to part A. If we now have a look at part B, we've been asked to estimate the time during this 50 seconds when the instantaneous acceleration equals the average acceleration. By instantaneous acceleration, we're referring to the gradient of the line at any particular point. So what I would first do is draw the chord from 0, 0 to 50, 30. This is essentially what we've done in part A. We've worked out the gradient of that chord, which is the average. Now we need to find the point or points on the line where the gradient of the line matches the gradient of that chord. To answer this question properly, you should be looking at drawing a tangent line at roughly where you think the gradients match. And we can see from the graph that that's between around 11 and 14. So any answer between 11 and 14 would suffice, but it's important that you have the chord and the tangent line on the graph. In question 25 we are given three functions, f of x, g of x and fg of x. And we are asked to find the value of d. Well, fg of x is a composite function. That means we do g of x first, and then we do f of x. So we do g of x and then do f to it. So that's the same as doing f to, well, obviously g of x, which is cx plus 5. But what is f of c of x plus 5? Well, we're told that f of x is that. But what's f of cx plus 5? Well, all we need to do is replace x with cx plus 5 in that expression. So we're going to get 2. Instead of x, we're going to get a cx plus 5. So we get a cx plus 5. And then we need to add c plus c. And if we expand that out, we're going to get a 2cx plus 10 plus c. But we are told that f of gx is 6x plus d. 6x plus d. Now in both of these we have an x term and a constant term. They must be equal. So this tells us that 6x equals 2cx. Well, we can get rid of the x's. That says that 2c is equal to 6, right? So c equals 3. And then the next bit tells us that d is equal to 10 plus c. But we know what c is. c is 3. So d is 10 plus 3, which is 13. In question 26, we are asked to rationalise the denominator and simplify this expression. Well, we've got a divided by root 5 here, so what rationalise is referring to is make sure we have this surd on the numerator and not on the denominator of the fraction. And in these trivial cases, all we need to do is multiply both top and bottom by root 5. So we're going to do that. Remember, if we multiply the top of the fraction by something, we must multiply the bottom of the fraction by the same something. Essentially, we're multiplying by 1, so the fraction remains unchanged. So if we do that, on the top we are going to get 10 root 5, and on the bottom we're going to get 3 root 5 times root 5. Well, that's 3 times root 5 times root 5 is 5. So this is going to give us 10 root 5 over 3 times 5. We can do a bit of cross-cancelling here. 10 and 5 becomes a 2 and a 1. So this gives us 2 over 3 root 5. And that is our answer. In question 27, we are asked to convert the decimal 0.172 recurring to a fraction in its lowest terms. Now when the dots are above the 7 and the 2, that means that the 7 and 2 parts recur, so it's 0.172727272, and that recurs. So how do I solve this type of question? Well, the first thing I would do is set x equal to that number. So I'm going to let x equal 0.1727272, and that obviously goes on forever. Now what we want to do is manipulate x in some way, i.e. times it by 10, 100, 1000, whatever, such that when we take that expression away from x, the recurring part disappears. So what multiplier should we go for? Well, notice that the decimal repeats in 2s, so we have 72, 72, 72. So the bit that repeats is 2 in length. So if I multiply by 100, this 7 here, for example, will move up to here. And so in essence, they would align. This suggests to me then that we want to try 100x. So let's do that. If x equals 0.1727272, then 100x is going to equal, we need to multiply this by 100, so we're going to get 17 point, and then we're going to get 2, 72, 72, 72, dot dot dot. Now notice that everything to the right of this 2 here is the same. So if I just put in a dotted line there, can you see that the tail end of these decimals are identical? So when we take these numbers away from each other, this bit disappears. So let's do that. We're going to do 100x minus x, and what's that equal to? Well, that's 17.2727272 minus 0.1727272. Well, that's just going to give us 17.1. If we clean up the left-hand side a little bit, we're going to get 99x equals 17.1. And that's an equation we can solve. Because I don't like having that decimal in there, I'm just going to multiply both sides of this by 10. So I'm going to get 990x equals 171. And this then tells us that x equals 171 divided by 990. And that is our answer. However, we need to be careful. The question asks us to give it as a fraction in the lowest terms. So this would only get us 2 marks. What we need to do to get the final mark is to try and simplify this fraction. How would I recommend we do that? Well, the numerator is quite tricky here, isn't it, to think of factors off the top of your head. So let's have a look at just splitting down the denominator. So what's 990? Well, that's definitely a multiple of 11 in there. So that's going to be 90 times 11. And 90 we can think as 9 times 10. So what I'm going to do is essentially decompose this 990 into its primes. Well, 11's prime, 10 isn't, that's a 5 and a 2, and 9 we can think of as 3 squared. And now we need to see whether 171 is either divisible by 3, 5, 2, or 11. Well, it's definitely not 5 or 2, is it? Because if it was divisible by 5, it would end in either a 5 or a 0, which it doesn't, so we can forget that. It's clearly not divisible by 2, because it's not even, it's an odd number. So that leaves us with 11 and 9. If you don't know this off the top of your head, let's try divide by either 11 or 3. Well, let's start with 11, shall we? We could do a process of long division, so if we start with our 171, and think what's an easy number of 11s we can do that we know off the top of our head? Well, I'm going to go for 10 11s, because 10 11s are 110. And then we take these away from each other. 1 minus 0 is 1, 7 minus 1 is 6, 1 minus 1 is 0. Now how many 11s go into 61? Well, I know already that we can't get a whole multiple of 11 out there. 6 11s are 66, 5 11s are 55. So we know it's not divisible by 11. So that leaves us with 3 squared, or 9. We could either try 3 or 9. I'm going to jump straight in with the 9, but if it wasn't divisible by 9, we could try 3. So let's do the same process. I've got 171, and this time let's think of an easy number of 9s we can pull out. Well, let's go for 10 9s, because that's 90. And now we're going to do the takeaway again. 1 minus 0 is 1, and then we've got the 17 minus 9. Well, that's going to give us 8. Now, how many 9s go into 81? Well, exactly 9 go into 81, right? 9 9s are 81. And if we add those together, we get 10 plus 9, which is 19. So this tells us that 9 goes into 171 19 times, so we can cancel this fraction down further. We're going to divide the top and bottom by 9, and we now know that 171 divided by 9 gives us 19, and we know if we divide the bottom by 9, then we're going to be left with 110. So this is our answer, and this and only this answer will get us that third and final mark. In question 28 we are given the diagram of the circle x squared plus y squared equals 10. That's the equation of a circle that is centred at the origin and has radius square root 10. We are told that the point P lies on the circle and has x coordinate 1, so I've marked in the x coordinate 1 there. We are given that the tangent at P intersects the x-axis at Q, so this tangent line here, and we need to find the coordinates of Q. How can we do that? Well, the first thing I would do is consider this dotted straight line here. So that straight line that goes from the origin to the point P. And why would I do that? Well, we know point P lies both on the line and the circle, but we have an equation for the circle and we know what the x-coordinate is. So we know that when x equals 1, 1 squared plus y squared equals 10, and that's at the point P. Yeah? So let's rearrange that. We're going to get that y squared equals 10 minus 1 squared, which is 9. This tells us that y equals 3. So point P has coordinates 1, 3. Now that's useful. What that tells us is the gradient of that line is 3. Okay, because it's the change in y over the change in x. That means, though, that the gradient of PQ, this line here, is the negative reciprocal of 3. Why? Because they are perpendicular. This is tangent to the circle, and the line I've drawn there is perpendicular at that point. And we know that the gradient of perpendicular lines are the negative reciprocals of each other. So therefore, the gradient of PQ is negative a third. So let's come up with a general equation for this line. So line PQ, we're going to have y equals minus a third x, we know the gradient, plus c. But we know P is on this line. So P is on that line. So we can use the coordinates to find out what the intercept C is. So let's plug those in. Well, at the point P, y is 3, and that's equal to minus third of x, which is 1, plus c. So this tells us that c is going to be 3 plus a third, which is going to give us 10 over 3. So the equation of the line is minus a third x plus 10 over 3. So now how do we find the point Q? Because we know Q lies on this line. Well, this happens when y is 0. So for Q, we're going to put 0 into this. So 0 equals minus a third x, which is minus 1 over 3 x plus c, which we know is 10 over 3. And if we rearrange that, we are going to get, I'm going to do it up here, that x equals 10. But now we need the coordinates. Well, we know that the y coordinate is 0, so the coordinates of Q are going to be 10, 0.